Hello everybody, my name is Vittorio di Cocco from Cassino University, Italy, and today I would like to propose to you a study on bath chemical composition influence on intermetallic phases damage in hot dip galvanizing, damage due to bending tests. In this work, we analyzed 4 different bath chemical composition in order to produce different coating zinc-based coated. And this presentation is composed by 4 steps. In the first one, I present to you the case study definition, in particular some words about hot dip galvanizing processes. And the second one is the manufacturing of the specimen used in our research. Then I'll show the mechanical test on pursued specimen, in particular the bending tests, and then the analysis performed by using a light optical microscope in order to observe the damage of the intermetallic phases. In this work, we used a very short furnace in a laboratory in order to realize our baths. The first one was a pure zinc bath, and the others are characterized by many different addition of elements like copper, or titanium or tin. In this slide, I show the influence of the titanium addition on the color of the bath, and it is possible to realize coatings using the same color that you can see in this slide. This is the same bath characterized by different levels of the oxidation, and you can see that we can have a traditional gray bath, or yellow in this case, or a violet, blue, and green, the other one colors. In order to realize our study, we produced a specimen characterized by a rectangular shape of 50 millimeters of length, width 25 millimeters, and the thickness is only 3 millimeters. These specimens are characterized by a chemical composition with high values of silicon. In this case, the material is a very reactive material into the zinc-based bath. The bath are prepared at the temperature of 450 Celsius degrees, and are characterized by a pure zinc bath chemical composition, and the other one used are characterized by a 3% of the tin, or 0.5% of copper, and 0.5% of titanium. The dipping time analyzed were 15, 60, 118, 300, and 900 seconds. Galvanized samples are used to perform bending tests, and the other ones are used to characterize the microstructure of the coatings using a traditional metallographic preparation. In this slide, we can see the steps of this preparation. The first one is the cutting of the samples by using a device which allows us to perform cuts without influence of high values of temperature due to the cutting. The second one is a machine that allows us to prepare short things able to put it in the metallographic machine, which is able to polish the surface by using abrasive papers, and by using aluminium suspension, we can achieve a preparation, very accurate preparation, like a mirror. Then these surfaces are etched by a chemical solution, Natali 1 for 30 seconds. Natali 1 is a solution containing alcohol, acetic alcohol, and 1% of nitric acid. And then the surface are prepared and ready to be observed by traditional light optical microscope. These are some results of the microstructure of the section of the coatings. This is the coating characterized by a pure zinc bath. In the first one, you can see for low dipping time the presence of two phases. The first one is the delta and the second one is the zeta. For dipping time of 60 seconds, you can see a thin delta phases, and then a zeta in this part of the displacement, and in the other part, this is the outer part of the displacement because the surface is in this direction, we have a presence of the eta phase. The eta phase is characterized by the chemical composition similar to the zinc bath, in this case pure zinc. Increasing the dipping time, you can see that the zeta phase is well developed, and the specimen characterized by 300 and 900 seconds of dipping time are characterized by high values of the thickness of the zeta phases. This kind of phases, delta, zeta, and eta, are present in the specimen galvanized by pure zinc bath, by bath characterized of 3% of the tin, and by bath characterized by 0.5% of the copper. The coatings characterized by a bath with 0% of titanium presents a delta phase at the interface between the iron and the coating. Then we have a presence of three phases part, where we can see a globular white phase, a lamellar phase around the white phase, and the presence of regular phases like this or like this, dispersed in longitudinal zones of the section of the coating, characterized by high values of the titanium. In this slide you can see the bending behavior of copper, zinc copper coating and the titanium, zinc titanium coating. You can see that the high values of the bending moment are achieved for high values of dipping time. This is due to the biggest values of the thickness achieved in both cases, titanium and copper bath. And the main differences are for high values of deformation. Here you can see that the titanium coating are characterized by lower resistance in terms of bending moment than the specimen characterized by 0.5% of the copper. The behavior of other dipping other zinc bath are characterized by the similar behavior of this because the phases are always the same. In terms of the damage, you can see that the presence of the radial crack characterized of all the delta phases. In this case, we can see here section coding obtained by pure zinc bath at 180 seconds, and this one is the section of the coding obtained by 900 seconds of dp9. You can see that the presence of the phases are almost the same, and the presence of crack greater in the delta phase. For in this case, some of these crack arrests at delta zeta interface, and the other one propagates in zeta, arresting in zeta phase or arresting in the eta phase. For high values of dipping time, all the crack arrests in the zeta phase or at the interface between zeta and the eta phase, like this. It means that in all the case, cracks, we have no cracks that achieve the surface. This is dangerous because in this case we can think that the coating are not damaged because on the surface we can't see the damage, but the damage is present inside of the coating, reducing the time for service of these coatings. In case of coatings obtained by bath with titanium, we can see that we have a presence of a few radial crack in delta phase and arresting at interface between the delta and the tau phases. We have another different damage. In this case is evident here. It's a sort of a delamination between delta phase and the tau layer. And sometimes we have intergranular crack propagation in the tau phases, in case of the tau phases. This is due to the brittle behavior of the tau phase. We can see an indentation of the tau phase obtained by traditional micro hardness machine, and the values of the Vickers micro hardness is very high. It's compared to the micro hardness of quenched steels, and you can see the brittle behavior due to presence of a secondary crack starting to the indentation like this. In conclusion, the chemical composition of the bath strongly influences the zinc coating phase formation, and the bending test confirmed that the phases composition influence the resistance of the specimen, mainly at high values of deformation. And the traditional coating, the crack start at the iron coating surface and propagate in the delta phase, resting at interface of zeta phase or in zeta phase or at the interface between zeta and the eta phase. Coating characterized by presence of titanium, presence radial cracks in the delta phase, and we can see a presence of a delamination between delta and the three phases zone, and sometimes we have a presence of an intergranular crack of the tau phase. Sometimes this phase can lose the position in the coating. Thank you for your kind attention.